Hi, this is Catherine Bao with the Houston Education Research Consortium, a program of the Kinder Institute for Urban Research at Rice University and the research practice partnership between Rice University and the 11 public school districts in and around the Houston area. Thank you for joining me today as we discuss findings from our student mobility and the continuous enrollment study. Today, we'll be discussing the spatial patterns of student mobility and the continuous enrollment. Specifically looking to answer the questions, are schools geographically clustered by student mobility rates, and what about continuous enrollment? In short, we are looking to see if high mobility schools tend to be surrounded by other high mobility schools. And similarly, if low mobility schools are surrounded by other low mobility schools. And might there be similar patterns for continuous enrollment as well? We proceed to explore those questions in three parts, and we find that 1. There are parts of the Houston area where high mobility schools tend to cluster with other high mobility schools. This is mainly in the central and urban part of the area. Also, there are parts of the area where low mobility schools cluster with other low mobility schools. These tend to take place in more suburban parts of the region. 2. There are parts of the Houston area where high continuous enrollment schools cluster with other high continuous enrollment schools, and the low continuous enrollment schools cluster with other low continuous enrollment schools. And 3, where we find clusters of high mobility schools, we tend to find clusters of low continuous enrollment school and vice versa, suggesting, perhaps not surprisingly, that patterns of student mobility and patterns of continuous enrollment serve as complements of each other. Okay, let's look at those findings in a bit more detail. But first, let's start with a quick overview of some key terms. For this presentation, we'll be looking at total mobility rate, which is the number of school changes that enter or exit a campus in a given year per 100 students. So if 17 moves came into a campus and 13 moves left a campus, that's 30 moves in total. And let's say the campus had 200 students. This will be 30 divided by 200. So we have 15 per 100 students as our total mobility rate. For continuous enrollment, any students in grade 3 or above qualify for being continuously enrolled. So we define continuous enrollment as the percent of qualifying students at the school who have been enrolled in the same district for 2 or more years in 3rd grade and 3 or more years starting in 4th grade and beyond. But as a shortcut, we can think of this as students who have been enrolled in the same district for an extended period of time. Finally, we use the term cluster to refer to a group of neighboring schools that are similar to one another. In this case, we are looking for clusters of schools that are similar in terms of their student mobility and continuous enrollment. In particular, we are looking for clusters of high and low concentration. Finally, this presentation has a lot of moving pieces to it. So rather than try to cover information on the full state of Texas, we instead limit this investigation to the greater Houston area. And here we see the 27 districts whose data were included, and note the 5 years of data used. Okay, let's dig into those findings in a bit more. Starting with part 1, asking, are schools geographically clustered by mobility rate? To make this determination, we start by calculating the total mobility rate for each campus in the greater Houston area. We focus on non-structural moves to make sure that we are not capturing failure patterns. And here we see a map of each campus's 5-year average mobility rate broken into low, medium, and high categories, shown here with the blue, gray, and orange dots. While this map is simply showing the mobility rate for all schools, we can already see that there are some areas with lots of blue, for example, in some of the suburban districts, and some areas with lots of orange, concentrated in more urban districts. But also, several spots where the colors kind of intermingle. In other words, we have blue dots right next to gray dots and next to red dots. To try and make more sense out of the data, a spatial cluster analysis was conducted that allows us to isolate groupings of schools with similar student mobility rates, and here is what we have found. Several clusters of high mobility schools emerged, with 301 campuses around the greater Houston area belonging to high mobility clusters. There are also clusters of low mobility schools with 211 campuses belonging to those low mobility clusters around the region. In total, nearly half of all campuses in the greater Houston area belong to a cluster. Looking at the high mobility clusters in a bit more detail, we see that they tend to emerge in the central and more urban parts of the greater Houston area. Now zooming in to see who is part of those clusters. The high mobility cluster to the north are made up of schools from Spring ISD, Aldine ISD, Houston ISD, Clay ISD, and Cypress Burbank ISD. It is worth noting that those schools are not all part of the same cluster. There are actually multiple high mobility clusters that happen to be near one another. Next, looking at the high mobility clusters in the southwest region, we see it is made up of schools from Alief ISD, Houston ISD, Spring Branch ISD, Katy ISD, and Fort Bend ISD. Next, let's look at the cluster towards the eastern side of the map. This cluster of high mobility schools are made up of schools from Northeast Houston ISD. Then looking to the south, this high mobility cluster are also made up of schools from Houston ISD, or more specifically from Southeast Houston ISD. Shifting gears, let's now zoom in to look at clusters of low mobility campuses. First, we see clusters of low mobility campuses popping up around the suburban parts of the greater Houston area, creating a type of outer ring. In the northeast corner of the map, we see a low mobility cluster of schools in Humboldt ISD. Swinging to the opposite side of the map, in the southwest corner, we see a second cluster of low mobility campuses made up of schools in Katy ISD, Fort Bend ISD, and Lamar ISD. Popping up back to the north, we found two sets of clusters. The first one in the farther north was composed of campuses from Conroy ISD and Humboldt ISD. Moving south a little bit, the next set of low mobility clusters was made up of schools from Cypress Burbank ISD, Clay ISD, and also Humboldt ISD. Then finally, moving to the southeast corner of the map, we see low mobility clusters made up of schools from Pasadena ISD, Friendswood ISD, Pearland ISD, and the Clear Creek ISD. So, recalling our original question, are schools geographically clustered by mobility rate? In short, the answer is yes. There are many schools around the Houston area that belong to clusters that have similarly high or similarly low mobility. Interestingly, those clusters tend to cross district boundaries, while at the same time, clusters did not tend to include every campus from any particular district. For this reason, it is likely that many of those factors driving the creation of those clusters may come from features of communities being served. At the same time, there are lots of schools that do not belong to either a high or low mobility cluster, despite being surrounded by such clusters. So before moving to look at continuous enrollment clusters, we finish part 1 by looking to see if there are campuses that tend to buck the trend near them. These will be bright spot campuses that have lower mobility rate while being surrounded by much higher mobility schools. Or conversely, those will be campuses that we call dim spots, where they have much higher mobility even though their neighbors are low mobility clusters. Here we have the results of the outlier analysis, with the red dots indicating schools with higher mobility relative to their neighbors, and the blue spots being the bright spots where schools have much lower mobility relative to their neighbors. What's important to take away from here is that in the central part of the map, where we previously saw clusters of high mobility, now we see bright spots. Then in the suburban districts where we found clusters of low mobility schools, now we see a smattering of campuses that tend to have higher mobilities than their neighbors. And to help crystallize what we are highlighting in those outlier analyses, we can zoom in on a few spots. To see what we mean, here are two examples of campuses. The upper chart shows a high mobility school surrounded by lower mobility schools, and the chart below that shows two lower mobility schools surrounded by higher mobility schools. Those outliers provide ample opportunities for future research exploring what contributes to them being so different from their neighbors. So for part 1, looking at clusters of schools based on student mobility, we found that about half of schools in the greater Houston area belong to a mobility cluster. Higher mobility clusters tend to be in the more central and urban parts of the region, while lower mobility clusters tend to be in the suburban districts. And finally, as we see those clusters, there are also campuses that tend to buck the general trend of their neighbors. For part 2 of the study, we revisited this question of spatial clustering, but instead of focusing on mobility, now we look at continuous enrollment. Results of the cluster analysis returned those clusters of low continuous enrollment schools made up of 122 campuses, seen here as the red dots, and the clusters of high continuous enrollment schools made up of 140 campuses, which are the blue dots here. In total, nearly a quarter of all campuses in the greater Houston area belong to a cluster. Okay, let's zoom in again on those clusters. First, let's look at high continuous enrollment clusters. Starting up the northwestern part of the region, we see clusters of schools in Cypress Fairbanks ISD making up high continuous enrollment clusters. Next, there are clusters of high continuous enrollment schools that go through the central Houston ISD. Finally, there is a series of high continuous enrollment clusters in the southeast part of the map, composed of campuses from Houston ISD and Pasadena ISD. Looking at clusters of low continuous enrollment schools, there is one in the north-central part of the area, made up of schools from Spring ISD, Clay ISD, and Aldin ISD. Additionally, towards the western side of the map, there's another cluster of low continuous enrollment made up of schools from Houston ISD, Alief ISD, Spring Branch ISD, and Katy ISD. Swinging to the east side, there is a cluster of low continuous enrollment in northeast Houston ISD. And finally, in the south, we see one more series of clusters made up of schools from Houston ISD, Stafford MSD, and Fort Bend ISD. Lastly, while we see those clusters of high and low continuous enrollment schools, we also examined whether there are schools bucking the trend of their neighbors, looking for outlier campuses. Here we see the map highlighting the outlier schools for continuous enrollment, with the red dots indicating schools with low continuous enrollment while having neighbors that typically have much higher continuous enrollment rate, and then the blue dots showing campuses with a much higher continuous enrollment rate relative to their neighbors. And to drive this point home, here we have examples of high continuous enrollment schools surrounded by neighbors with much lower continuous enrollment, and also examples of lower continuous enrollment schools surrounded by ones with much higher continuous enrollment. So takeaways for part 2. First, about a quarter of schools in the greater Houston area belong to a high or low continuous enrollment cluster. Higher continuous enrollment schools tend to cluster in the central and the southeast part of the region, while clusters of lower continuous enrollment schools are found in the southwest and central regions. Finally, similar to what we saw earlier for the mobility cluster, there are also schools that buck the general trend of their neighbors when it comes to continuous enrollment. That is, in high continuous enrollment clusters, there are campuses with lower continuous enrollment and vice versa. Finally, for part 3, we wanted to try and bring the first two parts together to compare the clusters from part 1, looking at student mobility, and the clusters of part 2, looking at continuous enrollment. Here we have maps of student mobility rate and the continuous enrollment rates side by side. The colors have been coded inversely to sort of mean the same thing. So blue dots on the left would be lower mobility schools, while the blue dots on the right would be higher continuous enrollment schools. So in this way, both of those point in the same direction, students moving a bit less. In looking at those maps, there are some complementary components. We see a lot of red dots congregating towards the left and the lower half of the maps. Similarly, we see a bunch of blue dots towards the upper left-hand side of these maps. There are also spots on the maps where there's less agreement between the two. Cleaning up the maps to look at any of the clusters of schools further highlights how there are some spots of common overlaps, while other spaces appear as clusters for any one but not the other. In this way, student mobility and the continuous enrollment appear to serve as complements of one another, or at least they somewhat do. But there are also ways in which those function in their own unique ways. So bring it all together and we can conclude that yes, there are clusters of schools around the Houston area that have high mobility and also pockets that have low mobility. Clusters of schools also emerge for continuous enrollment. Second, there is a degree to which mobility and the continuous enrollment work as complements of one another. Where we see high mobility, we tend to see low continuous enrollment and vice versa. Yet while we see those clusters around the area, there are also schools near those clusters that buck the trend, working as outlier campuses. And lastly, what can we do with those findings? For starters, highlighting clusters of schools with similar level of mobility and similar level of continuous enrollment bring attention to how those schooling phenomena are concentrated in certain parts of the region. This is important for raising questions about some of the features of those areas that may contribute to shared mobility levels or continuous enrollment levels. Second, even in the context of concentrated high mobility or conversely low continuous enrollment, there are campuses that deviate from the overall trend. For some, those schools are bright spots that can be learned from. What are they doing that is helping them bring down mobility or riding up continuous enrollment, while their neighbors may be struggling? Conversely, there are other schools, the dim spot campuses, where mobility might be a bit higher than their neighbors or continuous enrollment a bit lower. Those schools also serve as opportunities for learning, particularly as it relates to identifying potential supports needed to address mobility, or perhaps additional services that would help the school as it deals with a uniquely high level of mobility. And there you have it. Looking at the spatial clusters of schools in the Houston area based on student mobility and the continuous enrollment. We hope you find this video informative and helpful. Thank you very much for your time. If you have any questions, comments, or feedback about what we have presented here today, please feel free to reach out to Dan Porter or me, Catherine Bao. Our email addresses appear on the screen. Additionally, don't forget to subscribe to the HERC YouTube channel to make sure that you will receive notifications when our next video is posted. Be on the lookout for additional ones in the coming weeks. Thank you again and have a lovely day.